Okay, so for simplifying rational exponents, all we have to do is, first for the exponent form, this would be our problem. Then we try to figure out what we can pull out of this 3 times to get 125. And it's 5. Because 5 times 5 equals 25. And then 25 times 5 equals 125. And then we'll get 5 squared, which would be 25. And that's how you find exponent form. With radical form, we'll find out that they're quite similar. We originally get this problem. So now what we're going to do is take this 3 and pull it out and put it here. And take this 2, pull it out and put it here. And this would be our problem. Then we know 5 times 5 equals 25, and 25 times 5 equals 125. Then, again, we'll get 5 squared, which will equal 25. And that's it.
This is the product of powers. What you're basically doing here is multiplying the numbers and adding the exponents, such as 4 times 5 equals 20, and then 20 times 2 would be 40. So, and then you add your exponents 3, 7, and 50, which comes out to 60. And that's all you have to do.
For the power of the power, basically, if you have an exponent and another exponent, you can multiply them together. So we take the 3 and the 2, and we can actually multiply them together and get 6. And then the answer will be 2 to the 6th power, which is 64. And that's all.
So, for the power of a product method, the exponent applies to everything inside the parentheses. So you multiply everything inside by 3. And when you work that out, you end up getting 27 x to the 6th, y to the 3rd. It's as simple as that.
So for negative exponents, all you have to do is take the negative exponent, which we have here, the -1, and circle the term so you don't forget what you're doing, and put it to the opposite side of the division line to get rid of it. So here we take that, take these both, the 2 and the -1, which we'll end up then with just 2 to the 1, no negative sign included, and that will then equal 1/2. That's it.
The zero exponent property is very simple. Everything to the 0 power ends up being 1. 7th to the 0, 1. 10 to the 0, 1. 100 to the 0, 1. And 1000 to the 0, you guessed it, 1.
Okay, so for the quotient of powers property, all you have to remember is that if you have the same number on either side, you can just take the exponents and subtract them to get the same answer. So here, you're going to take 7 and then subtract it by 4, and that will equal 5 to the 3rd power, which we all know is 125. And that's all you got to do.
The power of a quotient is rather complicated. You start off with your set here, and what you do is you cancel out any like terms, like your x's, 2 on the top, 1 on the bottom. So they cancel out to 1. Y's, 3 on the top, 1 on the bottom. Those cancel out to 2, and you have your lone z. Then, when you're done with that, you distribute your 2 to all the numbers. And then you end up with your answer. 9x2 y to the 4th z squared over 16.
Hang time! Okay, Gianna, spelled with 1 N this time, and Oscar are happy that they are finishing their video. To celebrate their process, they jump for joy. While jumping, they remain in the air for 2 seconds. Upon landing, they decide to find out exactly how high they jumped.
To find how high we've jumped, you have to use this equation. T, representing time in seconds, equals 0.5 radical h, h being your height. You substitute the t with the amount of seconds we jumped, 2 seconds, and from there, you work it out.
The next step to solving it is realizing we have 2 equals to 0.5 radical h. Now the first thing we're going to want to do is get rid of the 0.5. So we divide each one by 0.5, leaving us with 4 radical h. Now we're going to try to get rid of the radical h. So we square each one, leaving us with 16 equals h. The jump was 16 feet. We were very happy, or at least Oscar thinks we are. Gianna with one N is still not happy about the way her name is spelled. Hello. I like pretty rough right now. It's the morning. Anyway, so when learning, what helps me best is seeing a lot of examples, because I am one of those that likes to follow steps and formulas to get, the work done. Overall, I feel pretty good about this chapter. I learned it, I think, pretty well. This is, my theme is Christmas, our theme, and just in case you didn't know, it's my little antlers. Anyway, so, I'm what you would like to call an otter lion, and my personality allows me to try to get things that need to be done, but along the way, having a lot of fun, which is what I like about your class, because you can learn a lot while having fun. I think that's the way learning should be, because people get involved and they want to do it. Okay, so as of love language, I don't know, that doesn't really relate for me to my learning style, but I guess it kind of does, because surprises and spontaneity and stuff that are like out of the normal or regular help me learn a lot, because it's like, guess it's fun to be different and learn different ways, and that's kind of the thing. So yeah, I hope you enjoyed our video. This is my room. Bye. Okay, so as far as Oscar goes, he couldn't be here with us today, so I am going to, and I quote, fill in for him. So he says the way he works is he enjoys working through examples that we do in class. He says that is the best way that helps him. He says that his learning is so perfect due to Mr. Suhu's amazing style of teaching. He says he is like a golden retriever in the way that he likes to help other people learning and just in general, And he says his love language is more like he likes to give gifts, which is understandable considering he's a golden retriever and he likes to help people. So that's how he kind of relates it. And he is so sorry he could not be on this video, but you know what? You gotta see more of me. That's okay. Everyone's happy. Okay. Merry Christmas!